how to find the or apply the fast Fourier transform algorithm. So we have gone through the steps, and right now today we'll do some practice problems. So the first, let's try a 4-point FFT. So this is the question. Let us consider a sequence say x of n equal to 1 0 1 0, and you have to find the 4-point FFT of the sequence. So as you know, the first step is you have to mention, let me denote your n value, n is 4. So what will be the total number of stages? Total number of stages, that is denoted by capital M. So that will be log 4 to the base 2, and that will be 2. So the value of capital M for this particular problem will be 2. So there will be 2 stages. You can solve the answer in 2 stages. Say small m represent the stage index, and the small m varies from 0 to, sorry, index should start from 1 to 2. So m for m equal to 1 for the first stage and 2 for the second stage. Now let's start the problem. So as you all know, we have to represent your input sequence as 4 points. So that should be in the bit reversed fashion, right? That's what we have seen in the last class. So let me find the bit reversed order first. So here, let me write the bit reversed order. So you formulate a table like this. First one should be your, say, natural order. So 0, 1, 2, 3 is your index. Now let me represent it in using 2 bits, 0, 0, 0, 1, 1, 0, and 1, 1. Now let me do the reversal. So 0, 0, 1, 0, 0, 1, 1. I have just reversed the bits. So this is the reversed bits. And let me represent it as the reversed index. Now let's see the new index. So this is 0, 2, this is 1, and 3. So initially what you have to write is x of 0, then you need x of 2, then x of 1 and x of 3. So that is the bit reversed index, isn't it? So let me see what is x of 0. X of 0, as per the given sequence, that is 1, and x of 1 is 0. So x of 1 is over here, so that is 0. And x of 2, x of 0, 1, 2, that is 1. And x of 3, 0, 1, 2, 3, this is x of 3, and that is 0. So this is my inputs. So this is what I'm feeding to this particular butterfly system. So this is what you have to do in the next step. This is the first stage. Let me draw the first stage. You know that in the first stage, there is separation between the arms. While writing the equations or while writing the steps, we have seen that separation between the arms of the butterflies, that should be 2 raised to m minus 1. So let me represent, or let me notate the calculations over here. So this is for the stage 1. Okay, so and stage 2 I will do over here. This is for stage 2. Let me represent stage 2 somewhere over here. This is stage 2. One thing, when you draw the diagram, this should have a lesser space compared to the next stage in DIT algorithm. So you know that as we increase the number of stage, the butterflies will get a bit complicated. So it's better to give more spacing for the coming stage. So if you have at a third stage, you give more spacing compared to the second stage. So let me denote the stage 1 calculations over here and stage 2 calculations over here. So stage 1, you know that m equal to small m equal to 1, here small m equal to 2. So what is the separation first? Separation was 2 raised to m minus 1. That was the equation. So 2 raised to 0, that is 1 unit. So the arms of the butterfly has to be separated by 1 unit. So if you start at this particular point, that can end after 1 unit. So this is one distance. So it can end over here. So here my butterfly can end at this point. Got it? Here you can write WNK. We will compute the twiddle factor, but we know that its WN is 4. So W4K. Let's find the value of K then. So this is the first butterfly. So there is a rule that no two butterfly cannot start from this particular point or cannot share a common point in a stage. So you cannot start a butterfly over here. Probably you may think that you can draw the next butterfly like this, but that's not possible because this point cannot be shared by two butterflies in a stage. Okay, in a single stage. So you're not supposed to start the next butterfly here. So this is the only point where I can start the next butterfly. So here to here, again, the separation is 1 unit. That's why I'm drawing it like this. And here you will have W4K. We will find the K value. Okay. So that's the first stage. Now let's find the k value. So k value was referred as the Tudel factor exponent, right? So k was given by the equation nt by 2 raised to m, and in our case n is 4. So this is 4t by 2 raised to 1. So you will get it as 2t, isn't it? Now let's see what is c, where t varies from 0, 1, 2, etc. up to 2 raised to m minus 1 minus 1, isn't it? So you just substitute the values. So you will get it as, you find this index 2 raised to m minus 1. M is 1, so 1 minus 1, 0. So this will be 2 raised to 0 is 1 minus 1. So this term will become what? 0. So it should go like this 0, 1, 2, 3, etc. up to 0. That implies it has only one value, right? It's not correct to say like that. So it is having only one value, that is 0. So the only value of t is 0. Therefore, what will be k for this butterflies? That will be 2 into t. So that is 2 into 0. So that will be 0 again. So for the first stage, the value of k is 0. So here I am giving k equal to 0. The same butterfly will be repeated with k 0. So we know that W40, the value is how much? 1, right? W40, because W40 means e raised to minus j 2 pi k is 0 by 4. So that will be e power 0, that will be 1. So you can substitute it value as 1 over here. So that is its value. Now let's find the output for the first stage. For the first stage, you will have 4 outputs, as we already discussed. For this butterfly, if A and B are the inputs, what is the output of first stage? A plus B into W and K, right? And here it is A minus B into W and K. So in our case, this is 1. So the output will be actually 1 plus this 1 plus, okay, 1 plus 1 into this is B into this is W and K. W and K value is 1. So 1 plus, for this case, let me expand it for a clarity. W40 into 1. So this is what A plus B into W and K means. So in our case, W40 is 1. So 1 into 1 plus 1. You will get it as 2. So this output is 2. And this will be what? 1 minus 1 into 1. So this will be 0. Because its output is A minus B into W and K. This is A and this is B and this is W and K. So 1 minus 1 into 1. So 1 minus 1, that is 0. And here it is 0 plus 0 into 1. So this will be 0 and this will be again 0. 0 minus 0 into 1. So this is the output of the first stage with your butterflies. Now let's move on to the next second stage. So let's calculate the separation. So what will be the separation between the arms? So 2 raised to m minus 1. So this is 2 raised to 2 minus 1. So that is 2 raised to 1. So that is 2. So if you start at this first point, where it has to end? It has to end after 2 units. The separation between the arms, these are the 2 arms that has to be separated by 2 units. So if I start at this point, this is 1 unit and this is 2 units. It can end only at this point. So this is how your butterfly will look like. Corresponding to that, you can draw the lower arm also. Now, after this point, this is the other point where you can start the next butterfly. So here, this point is not shared by any other butterflies in this particular stage. So you can definitely start a new butterfly at this point. Again, this is corresponding to this point. You can see the point. So it should end after 2 units. So this is 1 unit and this is a second gap. So it has to end after 2 units. So this is how it should look like. So you can draw the lower arm also based on that. So this is how the lower arm is. And here you can mark your W4K value, W4 whatever it is. And here you have the next Tudel factor, W4K. Let's find the value of K right now. So how can you find K? K is nothing but NT by 2 raised to M. So N is 4, T by 2 raised to M. M is 2 over here. So 2 square 4 and 4 will get cancelled and the answer is T. Now let's find the value of T. T varies from 0, 1, 2, etc. up to 2 raised to M minus 1 minus 1. So 0, 1, 2, etc. up to, let's find these values. 2 raised to M minus 1. M is 2. So 2 minus 1, 1. 2 raised to 1 is 2 minus 1. So this will be 1. So actually, this and only possible values are 0 and 1. So the fact is that Here you have two values. Let's find k now, right? Therefore, k is equal to t. The values of t are 0 and 1. For example, just assume that the value of t was 2t. If it is 2t, what will happen? K should be how much? 2t. That means when t equal to 0, k will be 0, and k equal to 1. When t equal to 1, k will be 2t. 2 into 1, that will be 2. So that in that case, the values of k will be 0 and 2. And in this example, particularly k is equal to t, so that the t value is 0 to 1. Same will be copied for k also, because k is equal to t. Now you have two values for k. So for the first butterfly, you will have to give the first value in the order itself. And for the second butterfly, you can give the second value. So you have W40 and W41. These are the identities of butterfly. So you can think like this also. When these two butterflies are separated by a spacing, this value will repeat. So when it is for the first, there is a spacing. That means these two butterflies will be identical. When it is W40, this will definitely be W40. Similarly, moving, if you look at the next question for the, let's try 8-point DFT. For example, you're trying an 8-point DFT. For the coming stage, you will have a spacing over here, and two butterflies will be overlapped like this. That means the same butterflies will be repeated after this particular gap. So that will be very clear with a higher number of stage problem. Okay, so let's find the answer for this particular question. W40, the answer is what? That is 1. So here the butterfly value is 1. Twiddle factor, not twiddle factor, yeah, twiddle factor value is 1. And for this case, W41, let's find the value of W41. So you may have to find an n number of W40, 1, 2, 3 values in a problem. So it's better always to detect or summarize all these values in one corner of your paper. So let's find W41, e raised to minus j 2 pi kn by n. K is 1 by 4. So this is e raised to minus j pi by 2. So this is nothing but cos pi by 2, or you can try it in calculation. See, I need to find the value of 1. We want to find this thing, right? So this is 1 angle minus pi by 2, isn't it? 1 angle minus pi by 2. So let me write in calculator 1, and sorry, it's 11. Angle minus pi by 2. So minus pi divided by 2. So the answer is minus j. So this is minus j. So let me write that's minus j. W41 is minus j. Let me substitute the value over here, minus j. Now focus over here. Here it's 1. The total factor is 1. Here it is minus j. Now let's solve the first butterfly. A plus, this is the first butterfly. What you will get over here? A plus, that is 2 plus b into wn, right? So what is your b value? Go to the lower arm of this butterfly. That is 0. 0 into 1. So that will be 0. So 2 plus 0. So the answer will be 2 over here. And let's find the next value. Let's find the lower arm value. That will be definitely, when it is 2 plus 0, this will be 2 minus 0. 2 minus 0. So that will be again 2. So this is the butterfly that we have solved. Just focus. This butterfly will make this butterfly a bit bold. If you are able to use different colors, you will be able to distinguish the butterflies. Okay. So in exam, you use some other color pen. So it will be pretty easy to distinguish between the butterflies. I think now it's very clear. One is bold and one is in normal font. Now let's solve these butterflies. Okay. What is this? 0 plus 0 into minus j, right? So that will be 0 again. And here 0 minus 0 into minus j. So that will be 0. So this will be your x of 0. This will be your x of 1. This will be your x of 2. And this will be your x of 3. So I hope you remember the one step that I have mentioned while writing the notes. If the input is in the bit reversed fashion for the DIT algorithm, if the input is in the bit reversed fashion, output will be in the natural order. That's why the index is in natural order, 0, 1, 2, and 3. So what is your final answer? Let me dictate my final answer over here. X of k is equal to 2, 0, 2, 0. And that is the final answer.